My background has been in large-scale data warehousing, databases, and business intelligence systems. I used to work at companies like Teradata, and before that at companies like Aster, before we started Arcadia. The focus of today's talk, I just want to have a discussion with regards to how we see our customers. We see a lot of companies that we work with utilize the cloud for a lot of data management and analytics, and then come up with a natural question: how do I make business intelligence tools work with this? How do I make my analysts, who are not necessarily coders, effective on this newer architecture, whether it's a hybrid or multi-cloud environment or a complete public cloud environment work. So let me start out. I'll go with a very canonical architecture of business intelligence for folks who have actually deployed something related to BI in the past. This is literally 20-year-old way of doing BI. Right? And so you have your data sources that you collect in your operational systems. Nowadays, you can collect them directly through streaming systems. One way or the other, the data sources typically get collected and managed inside a warehouse. The warehouse could be your enterprise level warehouse, which is one common repository where you could join data or combine data from a lot of sources, or it could be more line of business focused, departmental in nature, but some sort of a scalable database would be utilized to manage this level of data in the first place. From there, when you start moving into actual analyses, you find business teams or individual teams wanting their own slice of the data. So they go in, spin up their own data marts. Why? Because the data warehouse might be locked down. It might take a lot of time to get projects moving on the warehouse. Why not take the subset of that data that is relevant to the project that I'm trying to work on, move it into a data mart. Again, powered by database technology, but very focused on a particular project, particular business use case that I care about. And then you move that into cubes, because you're now trying to report on this. You're trying to push dashboards, which are broadly consumable, not just a few users using it ad hoc, but used by a lot more people, perhaps inside the organization, perhaps even partners outside the organization. And so that's where cubing technologies come into the picture. Cubing servers from Microsoft, cubing servers from Oracle, and the kind. Eventually, you get to the visualization, the reporting layer, which is the tooling at the UI level, which in the era of 2000s, that used to be tools like Business Objects, OBIEE, which is Oracle's business intelligence tool, Cognos, and a bunch of other tools. And that's really how you would think of deploying a BI project. You would say, hey, I need to have a dashboard. I need to make the dashboard or a set of dashboards in an application production ready. This is more or less the architecture you would think about because this is how it has been built over time. What are the key principles in this design? So if you just take a step back and you see what's happening on the picture that is on the left side of my screen over here, you see the first thing is there is a co-location of compute and storage. So wherever I need to do any kind of interesting analysis, if it's at the data warehouse level where I need to do some ad hoc SQL preparation, ETLing of the data, I'm moving the data into the storage that's associated with the warehouse. If it's in the mart where I'm actually doing the analytics, then I'm moving a subset of the data, a slice over there. Same holds true if I'm actually reporting at a high concurrency with a low latency of performance. I'm moving it into the queue tier or the in-memory tier associated with my BI engine. The data does get duplicated in multiple systems, but that's okay as long as I can manage the governance and the security over it. As long as I'm okay with a process that says the data down at this warehouse is equally secure as a copy or a subset of the data up in the queue, I'm okay. So I should be able to rationalize this with a governance process around it, but as long as I can do that, I'm good to go. And the data is naturally summarized. As you move up the stack closer to the user, the data gets lesser and smaller in volume because people are looking people are allowed to look either at a slice of the data or they are looking at more summaries of the data, which give you a better indicator to start off with. So these are the key principles that work in this design and make this design pretty much a standard for wherever you deploy BI. This is the design that you use. Even to this day, you will find far more architectures deployed in this pattern with business intelligence on-prem, in the cloud, or in hybrid environments. But when you come to the public cloud, the core principle, one of the core principles and one of the core value propositions of the cloud is that it is built on a decoupled compute and storage. The idea is you should be able to scale as much storage as you want. You should be able to store petabytes, literally petabytes of data in the cloud at a reasonable price point. And you should be able to compute at a different scale. You might want it on a small subset, you might just use a few compute nodes. You can want it on a higher subset, you could use hundreds, potentially thousands of instances and compute at the compute layer. Whether they are instances, whether they are containers, or what you find now, where you move into serverless paradigms where it's just functions that you want to run on the cloud providers, right? This is the core that the cloud is built on. It's the flexibility that it provides. It means that every time I am interested in increasing the capacity of my warehouse, I'm only thinking about increasing the storage capacity. I don't have to pay the cost of increasing the compute capacity. I could have a petabyte store data warehouse with lower compute power if that is what I need. That's the flexibility that the cloud is really built on, and that's the decoupling of the compute and the storage that it provides. So if you take this architecture, you do the first thing, you deploy it, migrate it, I call it lift and shift, you can call it a migration into the cloud. What does it look like? So in the cloud, what you do is you take the data sources that sit at the absolute bottom of this pyramid, if you may. You move those data sources into the cheap storage, either into a data lake style storage if you're using Azure-based storage, or object store, more familiar in the Amazon environment with S3. That's where you start storing it. You optimize a little bit more between S3 and Glacier because that's where some economics can come in. But the idea is you add another layer to the cake of your business intelligence pie that you're actually, or of the business intelligence pie that you're actually building. And then the warehouse feeds from it, right? And you can, depending upon whatever technology you're using, you can easily map individual names of technologies to what I'm pointing out over here. You have at the storage layer S3, could be going into Redshift, could be going into another database which is very department specific, eventually being exported into a Tableau machine which has a Tableau server, that's the cubing and extract tier. Eventually there is a dashboard built on it that other users are consuming, right? And that can be applied with a mix and match of combinations across the technologies that you deploy. The good thing is now with the migration, all of these technologies in varying stages of maturity are available in the cloud. You could find a good data warehouse in the cloud. You could find a better one than what Redshift is even today, or you could find Redshift doing a better job of it than what's available out in the market as well. Similarly, at the BI tier, you'll find almost every business intelligence company out there trying to make sure that the BI cubing engines or the BI in-memory engines are available and ported on the cloud computes that are available. Right? It keeps the principles the same. It allows users to think from the same basis that they have since the legacy designs, but leverages the infrastructure and the flexibility of the cloud that is available. It's well suited, if you look at it, it's well suited when your analytics can be done with small and medium scale data. If your data is not something that requires you to go across a substantial portion of your storage or a substantial portion of your data lake sitting at the bottom, then this works very well. You can summarize it, you can take a subset of it, slice it, extract it, and work very well with the visualization options or with the business intelligence options that are available over there. It misses the mark when you are trying to control the increased governance. The governance that you already have in place with the 4 tiers above has now an extra additional layer that you need to worry about. You need to figure out how the processes or how the ETL is moving into one extra hop before it goes downstream, and how the security around that is going to be managed. It increases the latency to analytics. Eventually, the people sitting up here at the top of the pyramid are not interested in how the data is flowing through the various systems. They are more interested in how fast they can get to the data from the time it was actually generated, from the time it was actually available for analytics. Right? So it increases the latency of the analytics. But as long as you can quickly move the existing paradigm over there, there is value. There is value if you can reduce the immediate cost from an infrastructure perspective, and that's really the value from the cloud side, which is I can reduce the infrastructure cost immediately. And that's what a lot of people started out with, until larger companies, these are all customers of Amazon, and it's an article that got published literally a month ago to the date, talking about the climbing cloud costs. The gray bar over there is the AWS bills of companies like Pinterest, Cap1, Adobe, Infor, Intuit on AWS in 2017 compared to the red bar in 2018. The y-axis is in hundreds of millions. The cost of infrastructure that you initially start seeing the benefits when you are picking and choosing smaller projects onto these public clouds quickly increases if you keep replicating the same legacy architecture over and over again. So this works very well because it got you started in the cloud in the first 6 months or in the first 2 months, and you get agility over there. But if you keep doing this, and if your entire organization is going to keep repeating this over and over again, for folks who have done this over a period of time, companies as varied as tech organizations like Adobe or financial services companies like Cap1 realize that there is a point where this is not viable from a financial perspective. Right? And that's really if you view companies over here as being 4 or 5 years ahead of where the rest of the market is in terms of adoption of the cloud, in terms of actually leveraging the public cloud infrastructure, this is literally looking at the future for a large section of the cloud market. This is not the value. This is not really what you think of when you associate cloud computing and you make the case of why I should be doing stuff in the cloud. So what gives? What is it that is giving? Because I sit in talk after talk after talk where Amazon is making it easy and cheap to do individual slices of work. I can go down to per minute billing on things like Glue, where I'm just running jobs or submitting Spark jobs. I don't even get charged for 15-minute intervals anymore. They are literally going down. They don't even want to talk about dollars. They want to talk about pennies for every task that we done. So here's what's happening. If you take a look at this architecture that we're talking about, a lot of it is lift and shift, and it's going against the core principle of what the cloud was built for. A cloud is optimized where you have common shared storage, common shared compute, and servicifying the individual functions. The data warehouse is a service. And you'll see now, the data catalog is a service. And you'll see in the Amazon ecosystem services like Glue. It's a free data catalog. You don't have to have a data catalog inside every database. You can have a shared data catalog. Everybody should be able to share with it. That's an interesting way in which they are solving the problem. And that's servicification, that approach of using shared storage in the cheap storage tier, and then having multiple functions of analytics being done on it, whether it is machine learning through my Spark clusters, whether it is business intelligence through my visualization tools, or straight up ad hoc SQL analytics. I should be able to do it on the same system. If I'm going to replicate the data across each of these systems, that's where I'm burgeoning the cost. It's a known pattern, but that also comes with the cost associated with the cloud. So a thought exercise over here is what happens for, specifically on the BI side, what happens if you turn this on the head? So instead of taking the data and moving it tier after tier into the BI level into closer to what the users can do at the level of BI, what if you take the BI compute and bring it down straight up to the data? Put it on the layer that is closest to where the data is stored, which happens to be multiple options. There is obviously container-based services, there is instance-based services available. So the idea of moving BI to data, or the idea of moving compute to data is not really new. Everybody talks about it, everybody tries to do it, but when you take a step back and literally look at how things get used, you realize that it remains just an idea. You realize that unless you deliberately try to design something or architect your deployment in that manner, you are going to lose that principle very quickly. When you can come back every 6 months and review it and say, hey, it's a good idea to move compute to the data, but what I'm doing is exactly the opposite. In fact, it's being done exactly in opposite manner, because that's how the lift and shift mindset is tuning everybody to move towards. And so if you take the cloud native architecture, if you really say I want to design a service that is native business intelligence on cloud, I really should not be having these tiers. I should not be in a fresh world. I should not be required to move data into a warehouse before I can actually do a report on it. Why is it required? It should not be required in an ideal world. And that's really where you can make the case of saying, if there is a compute tier, a horizontally compute tier, or a scalable compute tier that can live on these direct stores sitting inside the public clouds, then it would be truly akin to moving business intelligence to the data. Your users can actually sit literally one hop away from where the data is. Making this a reality is where the challenge lies. Right? And this is a very good picture. It looks nice, looks clean. Clean is equal to cheap, or clean is equal to simple, and simple is better. To make this work is where interesting challenges come up. So I'm going to talk about, in the next half of my of this talk, I'm going to peel this a little bit more. To make this a reality, if you really want to put a user directly on the data sitting inside S3 or in your ADLS, which is a data lake stored in Azure, what do you really need? Where is the absence of the database? Where is the absence of, where does the data catalog go? How are you going to secure the data? How are you going to govern the data? Turns out at Arcadia, we work a lot with customers, and we work in this segment of the market, which Forrester describes as in data lake BI. They don't make the distinction of where the data lake is built, whether it is built on-premise using scalable Hadoop clusters, in the cloud using object stores. Their point is, if you want to be agile, one of the core things that you want to do is to physically bring BI to the data. We work a lot with customers who are challenged with these kind of choke points. And you see over here, the core is you eliminate the choke points that are generally there in the multi-tiered architecture that exists. Arcadia focuses on, as I said, data lake BI. Companies are now choosing large organizations are choosing two standards for how to do their BI. There is a standard for how to do BI if I am thinking from a data warehouse first world. Data warehouse is useful and it must be there because I have a common governed way of rationalizing the data. Then there is data lake BI. If I have significant chunk of data, and most organizations do, in a data lake, and if I don't want to call it a data lake, I can call it something else. But if you want to do direct business intelligence on it, you want to essentially do it in a manner that is native to the data lake. Arcadia focuses on the data lake BI side of the market. So as we work with customers, what do we find, right? When you say you want to make that nice architecture, picture, storage, immediate distributed BI compute, and users to actually work, first and foremost, you have to get the users. You have to be able to take an analyst and make them functional. You have to make it self-service for them. You have to make it simple for them. Business users should be able to analyze data not just with a simple drag and drop interface, which is pretty common, but now in the BI side you see them evolve into natural language based querying. And that's important to provide, because without that the users will keep pushing or moving towards the, let me take a subset of the data out, let me move it to another system, because that works very well. The second is you need an architecture, an Untitled BI engine that is going to be scale out. It will work in a distributed fashion across across a large set of cloud services, whether it's in Amazon, Azure, on-premise, in Hadoop-based clusters. And the third one, the most non-trivial part of this is if I do this, I need to work with services around security and governance, services around metadata, security and governance, which are shared and separate from the individual instantiations of these objects. Services like Drew, or if you have been following what Cloudera has been doing with their enterprise cloud, services like the SDX, where they actually take the notion of a data catalog, they take the notion of the security and the policies, and make that a separate shared service that multiple functions can plug into. My machine learning jobs could be over there, my data warehouse jobs could be going over there, my business intelligence reports could be going there as well. That's a shared catalog. You don't have to have one catalog for the warehouse and then yet another way of describing the data when you're doing your ML-based modeling or ML-based analysis. So these three are core requirements when you think of enabling that kind of an architecture. This is what we built in Arcadia Enterprise. This is our product. It has two core pieces, right? The first one is the distributed BI engine. It literally runs on a set of compute instances or containers. Doesn't matter what you pick. The idea is that this is a scale-out version of the business intelligence tier that typically exists, but it is stateless. It does not require, it can be completely shut down. You can take this entire tier away at places or at times when you don't want to do any kind of BI processing. So it has been built and designed to be stateless and completely fitting inside the way you think of cloud services. What you realize is if you build an architecture like this, start reading and writing data from object stores, they are great at reducing the bill of storage. They are not so good at the performance, especially when the data is large. So you need to have some tricks up your sleeve, some core innovations that you have to do to be able to say, I have a terabyte or 100 terabyte data set sitting inside object store, which by the way is not uncommon anymore. The phrase that comes to mind when I think of S3 is speaking to someone from AWS, and they casually remarked one day, they said, the legacy petabytes that are sitting inside S3 now. So there's a ton of data that just sits over there. The I/O, or the ability to actually analyze it fast, has to be built with software over there. And so what we do in Arcadia, we build what is called analytical views. These are pre-computed forms of the data that are very tied to specific reporting and applications that we are seeing the customers or we are seeing the users do. And they are automatically recommended, so it's basically an automatic structure that gets generated in response to how the queries are coming in, and incrementally maintained, which is another important piece. As you keep changing the data, adding, restating, deleting the data, you should be incrementally changing these downstream structures. You should not require to scan the whole data set before you get an answer. And it's important because, again, you're optimizing for this bottleneck. There's potentially a large number of compute over here, literally in the hundreds. Some of the largest customers are actually running hundreds of these compute nodes. And there is a significant amount of object store based data which is sitting over here as well. This bottleneck needs to be addressed before you can actually provide high performance reporting on this. Arcadia, on the front end to the end users, we provide native visualizations, front end that is very simple, self-service, easy to use, as well as we will connect to any BI tool that the end user wants to use. If there is a lot of training that someone has put into tools like Tableau, tools like Click, tools like Power BI, they can easily connect with us as well. The idea is that the layer cake that needs to come with those tools can be eliminated with the architecture that Arcadia has. So I'll give you an example over here of what we mean by smart acceleration. Because one of the core pieces of making this work is you can layer it out, you have a large amount of data, it's well described inside your data catalogs. The next problem comes in, how do I optimize it, or is it going to automatically optimize? I'm going to show you an example of how the system automatically optimizes. So here, this is the Arcadia UI, and this is a dashboard that is built. It's literally built on, as you will see, the record count indicate over there, slightly north of 1 billion records of data. So I'd say in this day and age, it's slightly greater than medium amount of data. It's not huge data. What you're seeing is the actual load times for some elements of the report. If I were to actually run a straight up SQL query on this data using any service out there, this is the run times that I would expect. It's 1 billion records. All data is sitting inside an object store. The filters of, the filter widgets at the top. There is going to be some sort of a trend of the channels which have been watched over day. This is another aggregation. Each of these questions, if you think of it from a BI perspective, these are aggregate questions that you're asking of the raw data. And it takes, as I was talking, you'll see it took about 25-30 seconds for all of this data to load, for this dashboard to load. It's great in that it's pretty fast, but it's not sufficient for me to say I'll put 100 users on this. So what I do is I can go back, select this. In Arcadia, I have the option of selecting Smart Acceleration. This is where, how do I optimize this in an architecture like this? When I did go to Recommendation Manager, it analyzed each of the widgets, each of the queries coming from the widgets, and generated over there in blue a recommendation for each one of them. When I say the get analytical view recommendations, it is actually generating those analytical views. It's saying these are the AVs, the combination of AVs that would be effective in speeding up this particular set of widgets. The AVs are interesting because they are not just tied to a single widget. Once you have an AV, it can be used for other completely different reports as well. I created the AVs, or I can quickly create the AVs by just clicking a single button. That's when it goes from blue to an orange color. The first part that I do with these AVs, this is where, because I have 1 billion records of data, I'm completely coming in from scratch on this system. I have the ability to refresh. I have to take whatever is there in the history of this data, and there was about a year and a half worth of history on this data. So I'm going to refresh it. When I clicked on refresh, I could do that. I'm doing it ad hoc over here. I could actually obviously schedule this job. So if your data is coming in every hour or every day, you can essentially schedule the job to incrementally refresh the analytical views that are depending upon the raw data sitting inside S3. And it'll automatically pick up only the changed partitions. If you're looking at Hive-style partitioning of the data, which is very common, then that's what happens. Here, you see some of the details. You'll see data reduction being an important piece. It'll show you some of the base table information. It'll show you the analytical view information. What is the resulting analytic view? This resulting analytic view, by the way, gets stored back on the same storage. So it's stored right next to where the actual raw data is stored. It's a much smaller data structure, but it is much more optimized to a certain set of the analytics or certain subset of the queries that are coming in from this kind of a report. Right? And each one of those will have the recommendations that we generate. If we fast forward a little bit, you will see as the analytical views get built, they go into a green state, which is an up-to-date state. I fast forwarded it by about 4 or 5 minutes. So I'm spending about 4 or 5 minutes telling the system to optimize the dashboard, which was taking about 30 or 40 seconds to load. Once that is done, I'm ready to go. Now I can say this report or this dashboard can be published to a broader number of users. And when they all turn green, I'll go back over to the visuals page. And click on that exact same report and see the change in the interactivity that I get. Now, I've literally cut out the stack, the middle tier pie that I was describing. This is a user from a browser literally performing ad hoc analysis on about 1 billion records of data, selecting whatever filter they want, slicing and dicing on 1 billion records directly sitting inside the object store. The beauty of this is not summarized data. So now if I want to go and say what is behind that red bar, I can actually click on it, get the detailed view of the data. It will pull up the exact raw records that are describing that particular red bar. Right? So the point is, I get to not have the limitations of only working with summarized data, but have the benefit of the speed of summarized data. And that's the best of both worlds. The reason you summarize data is you potentially get a large amount of performance benefits. And that's the benefit with smart acceleration. Right? This is what you need from a software intelligence perspective to be able to say, hey, I'm going to be able to directly run distributed BI on my object store. Without this, what you do is you start optimizing layer after layer, or you say, let's take a slice of the data, extract and make a summary of the data into another tier. So in summary, I can get to that. A lift and shift architecture works. It works sometimes, especially when the data is small and medium sized. If it gets replicated too many times, there is enough evidence out there about the burgeoning cost of infrastructure bills, because that does not come for free. It comes with 5 or 6 or 7 different provision systems. Each one is charged separately, as well as there is not just the cost of the service, but the cost of actually moving data across each one of them, the ETL cost of keeping those jobs up and running. Decoupling of the compute and storage is truly only useful if there's an architecture that leverages it. And I'm looking at it from a very, very, very specific BI perspective, but this applies broadly. It applies when you're doing machine learning and you say, I want to do machine learning. Do I have to take the data and copy it out into a SaaS server, or can I actually run a Spark job sitting inside the object store? There is inherent benefits inside moving the compute to where the data is stored. Duplication of data is not there. You have the ability to elastically scale up and down, and you must have the capability to automatically optimize. Otherwise, this just remains a chart or a dream that is nice on paper and a good theoretical exercise, but in practice, it cannot be done if there is no automation in the system.